we will talk about ECG paper. ECG paper, if you see ECG paper, and all you must have already seen, there are big square and there are small square. One big square contains 25 small square. So, throughout their ECG paper you will find this. Now, what is the standardization? See, standardization is ultimately when ECG records, what ECG records is the records potential difference between two leads or two electrodes. So, when it records and when the electricity generated during action potential is 1 millivolt, it will record 10 millimeter of deflection. So, when there is a 1 millivolt of potential difference between two leads, 1 millivolt, then ECG will record 10 millimeter deflection. This is default setting, means machine is made in such a way that when between the two electrode the potential difference is 1 millivolt is generated during action potential, the ECG pointer will move whether positive or negative whatever way 10 millivolt. So, that is what we call 1 millivolt equal to 10 millimeter. This is a default setting, machine's default setting, but there are setting in the machines where you can change when ECG machine records the deflection or potential difference of 1 millivolt, but you want this to be changed. You can make it 20 also, I will tell you why, or you can make it 5 also. So, for example, if I do standardization setting 1 millivolt equal to 10 millimeter, 1 millivolt equal to 20 millimeter and 1 millivolt equal to 5 millimeter. So, at the beginning of the every ECG you will see one square pattern like this, and it is by default always equivalent to 2 big square. So, it is 10 millimeter, 2 big square na. So, because this distance is 1 millimeter, 1, 2, 3, 4, 5, so this is 5 millimeter, this is again 5 millimeter. So, this is one big square is 5 millimeter by 5 millimeter. So, 2 square is 10 millimeter by 10 millimeter. So, standardization is 10 millimeter per millivolt, or 1 millivolt potential difference will generate 10 millimeter of deflection. So, what happens many times the ECG complex are very small, means suppose this is average ECG, and if you are recording very small pattern of the QRS complex and you are not able to read, what you do? You do 1 millivolt equal to 20 millimeter. So, exactly double of this it will be recorded. But while calculating anything, like it will come whenever there is a hypertrophy or enlargement, you have to calculate this length or this height. So, while calculating you have to make it half, because you are recorded with 20, double the standardization. Or sometime patient has so big waves that this waves moves out of the paper. So, and suppose there are 3 leads, it is going on. So, they mix with each other. So big waves. The reason behind naturally is a left ventricular hypertrophy or so. So, when there is a big deflection, so that you are not able to measure because one is mingled with other. So, in that case you make standardization 1 millivolt equal to 5 millimeter. So, the deflection will be half. But while interpreting, you know that now we are first you set 10, this is 20 and this is 5. So, when you put this 20, there is a setting. So, you have to do manual setting, not auto. Auto it is always by default 10. So, manually 20 millivolt per millivolt, 20 millimeter, here 5 millimeter per millivolt. So, you see, you again if you change the setting you will see very small square. So, 5 millimeter. But while calculating you need to do double. So, if deflection is 5 millimeter or 6 millimeter, you have to, while calculating you have to do it double, 10 millimeter. Remember that. This is standardization. I will summarize this again. See, do not get confused. ECG standardization is 10 millimeter per millivolt. So, when there is a potential difference generated by the heart is 1 millivolt. So, between these two leads, suppose the potential difference is 1 millivolt is generated when you are taking this. Simultaneously, it will record 10 millimeter of deflection by default. If potential difference is generated 1.5 millivolt, so it will record 15 millimeter deflection. If it is 20, it will record 20 millimeter of deflection. Depends on the how much is the potential difference between the two leads. Now this you can change. If the potential difference is less, suppose 0.5, so it will record a small wave because 0.5 will be equivalent to 5 millimeter. But if you are not able to read, you change the setting. There are knobs here. 1 millivolt equal to 20 millimeter. Here 1 millivolt equal to 5 millimeter. 10 millimeter is the default setting. So, if you press this switch, when the potential difference is 1 millivolt, it will record directly 20 millivolt, 20 millimeter deflection. And when the natural complexes are coming very big, then you reduce it to half. When you reduce it to half, then it will come, suppose if it is potential differences generated is 1 millivolt, it will record only 5 millimeter deflection. Now again you see, suppose this R wave height is 13 millimeter, you measure 2 big square and 3 small lines. So 13 millimeter R wave means how much potential difference has been generated? 1.3 millivolt, right? But if I do standardization double, it will record 26 millimeter height of the R wave. It will record 26. But I know I am recording at 22 millimeter per millivolt. Then while calculating, I have to make it half. So 13, again it will come to 13. And by default, when the complexes are big and it is going out of the paper, I will do standardization half. This is standardization default, this is double and this is half. So it will record 6.5 millimeter. So electrical potential difference generated is 1.3 millimeter, but record is 6.5 millimeter because it has recorded. But while calculating, I have to do this double. That's all. Understood? We saw standardization. Now we see time. So what happens? Paper is like this. Paper is coming out like this from the machine, like this. It is coming out. So it is traveling, time traveling. Voltage is up. More the voltage, upward deflection will be more. But paper coming out of this, like this, from the suppose this is the from here the machine ECG paper is coming. So once you press, the paper is coming like this. So this is time. So what is default time? Default time is 1 second equal to 25 millimeter default. Again here also we can make default. Here also we can make the change. How? Suppose this is 1 second strip. Let it be like this. So there will be 1, 2, 3, 4. 1, 2. Anyway, so 1, 2, 3, 4, 5. There is a, these are the 5 millimeter, na? 5 small square, na, here. So 5, 5, 5, 5, 5. So 5 millimeter. So in 1 second the time will travel 25 millimeter. So if in a manual mode, if you start the ECG machine, the paper will come out 25 millimeter in 1 second. So 1 second equal to 25 millimeter. So now what is the distance between these two lines in time I am talking about? This is point, so 5, 1, 2, 3, 4, 5. So 1 square will be of 1 big square will be of 0.2 second. So 0.2 second, 0.2 second, 0.2, 0.2, 0.2, 1 second. So and so in 0.2 second the paper will travel this much, and between these two lines it will be 0.04 second, or in short 1 divided by 25. 1 second 25 millimeter is 0.04. So distance between two small square is 0.04 second. So one distance between two small square is 0.04 second. Distance between two big dark line is 0.2 second, and in 1 second it is 25 millimeter. But this is default setting, but it can also be changed. You can make it 150 millimeter per second. Suppose if the patient's heart rate is very fast, so you are not able to evaluate the small waves here. You don't know what you want to see it very clearly. So you make the speed 50 millimeter per second. So now this will be exactly double. In 1 second this much paper will come out. So the complex will be bigger. So at least this distance will become like this. So now it is much clear for you to see the waves, but while evaluating you know that this is 50 millimeter. So it is actually double speed. So it is actually half of the you have to do the half the rate of this, whatever is that. And third thing, if patient's heart rate is very slow, so what do? You do 1 second 12.5 millimeter. So default 25 half. So the paper will come out very slowly, and patient then will have complexes near to each other. So there are 3 settings. Default setting is 1 second 25 millimeter. If there is a very high heart rate, you can increase to 1 second equal to 50 millimeter. When there is a heart rate is very slow, you can record manually 1 second equal to 20.5 millimeter. That's all. Now we saw standardization, we saw time. Now from time we will derive how to calculate the heart rate. Suppose if the heart rate is regular, suppose how these waves are generated, that I will take a topic, but with this I will tell you that how to calculate heart rate from the ECG machine. See, our time is 25 millimeter per second. So, always two things you see, it is written on the paper downstairs somewhere, is 25 millimeter per second. So, you and 1 millivolt equal to 10 millimeter. This is standardization and this is time. It is written on each auto paper. Now manual or now latest machine, they have all the printing. So, people they just don't pay attention to this, or they don't understand this, what is the 1 millivolt and all these things. So, consider this 25 millimeter per second ECG. So, now when 25 millimeter per second, so in 1 minute it will cross 1500 small square or 300 big square. Understood? So, there is a background, this is ECG paper. So, what you do, 25 into 60, because in 1 second it is 25, in 60 second it will be a 1500 small square. So, this 1500 line in 1 minute. So, what you do, suppose this is P wave, this is R wave, this is R wave. So, see the distance between these two and calculate the number of small lines. Suppose there are 4 big square and there are 4 lines, or there are 5 big square, suppose there are 5 big square between this. So, 5, 10, 15, 20, 25. So, 1500 divided by 25 equal to 60. So, patient has heart rate of 60 beats per minute. Suppose if the R wave distance between two R wave is 3 big square or 15 millimeter, 1, 2, 5, 10, 15, this distance is 15. So, 1500 divided by 15, so it is 100 beats per minute. So, if you want to calculate heart rate, just divide the number of small square between two R wave and divide it 1500 divided by number of small square, or 300 divided by number of big square. That's okay.